All right, here to begin our discussion on heart valves. So the last little bit of this chapter, or I should say this section, that there's more to the chapter, but with this heart anatomy section, we get into the heart valves. So heart valves have one primary role, right? They're going to ensure unidirectional blood flow through the heart. So blood flow in one direction. So we want to keep blood going in a single direction and not allow backflow. Backflow is not good. Too much turbulence would be created, too much extra effort that the heart would have to undergo. So heart valves are broken into two types, and we've mentioned them a little bit. So what we call the AV valves, atrioventricular valves, and the semilunar valves. But let's address the AV valves first. So the AV valves, atrioventricular valves, prevent backflow into the atria when the ventricles contract. That's their main job. So the ventricles are going to contract. We don't want blood to go up to the atria. We want blood to go out through the arteries. So our AV valves prevent backflow, and they're going to be comprised of the two types, right? So the tricuspid on the right side and the bicuspid or mitral on the left side. All those terms are used interchangeably. And I don't know why anatomists do this. It makes things more complicated, but they all mean the same thing, right? So the left AV valve, also known as the bicuspid, also known as the mitral. The right AV valve, known as the right atrioventricular valve or the tricuspid valve. So just kind of pick a term that you like that makes the most sense to you and go with that. So attached to the valves themselves, these little flaps, or we have these chordae tendineae. So the chordae tendineae anchor the AV valve cusps to the papillary muscles. I like to make the analogy of, let's say you're in a parachute and you're holding on to the strings, right? So the parachute itself would be the valve, and then the little strings that you hold on to would be then the chordae tendineae. So another set of valves are we call the semilunar valves. Semilunar, half moon. And to me, they don't look like half moon, but I didn't name these things. So semilunar valves prevent backflow into the ventricles when the ventricles relax. So the ventricles contract, blood goes out of the heart. We don't want blood to come back into the heart, right? So we're going to have semilunar valves at the aortic junction where the aorta meets up with the ventricle, and the pulmonary semilunar valve at the pulmonary trunk as well. So aortic on the left side, the pulmonary on the right side. So here's a cross section of the heart, right? So looking at then this cross-sectional view, we have our tricuspid. So 1, 2, 3. So we know we're at the right AV valve. On the left side, we have the mitral or the bicuspid. And here we have shown in red indicating oxygenated blood. This would be our aorta. And again, maybe they make sense to you. Maybe that looks like a half moon to you. It doesn't look like that to me, but they're the semilunar valves, right? And then here the pulmonary trunk, so the pulmonary semilunar valve. So 3 important valves, kind of showing you the position of each one. And again, important anatomical and physiological aspects of the heart. So here's an actual picture. You can see it's not as clean, more difficult to see. Our aortic semilunar valve, our pulmonary semilunar valve, and here we have our mitral, so the left side, and then the tricuspid being the right side. Here's a really nice view of the chordae, right? So the chordae tendineae holding the valve flaps, in place, and then the papillary muscles. So the papillary muscles, they're a muscle. They can contract, they can relax, depending on how much effort needs to be done to hold those flaps in place. And again, the cross section. So we see our left ventricle and our right ventricle. And how do we know that this is the right and left? We look at the thickness of that myocardial wall. So very thick. There's our intraventricular septum. And we can see then that actual sort of valve itself, there. And then the little chordae, and then the connection to the papillary muscles there. Now, this is an important physiological discussion, right? How do the valves actually work? We know they're valves, we know that they prevent backflow, but how do they accomplish this, right? The AV valves are going to work based on pressure, right? A lot of the system's going to work based on pressure, but the AV valves are going to work sort of in this way. So they're not functional in this sort of motion from top to bottom. So there's the atrium and there's the ventricle. So if blood puts a little bit of pressure here, no problem. Blood is going to be able to move its way down, which is what we want. We want blood to go from the atrium into the ventricle with no problem. Once the blood is in the ventricle, and once that ventricle contracts, there's pressure, the blood tries to go back. The blood tries to go back up to the atrium. It's going to put pressure on that sort of AV valve, that little flap. And the more pressure we put, the better seal that's going to happen. And the job of, again, the chordae is to not let that valve prolapse and just kind of, bust open, right? We don't want that to happen. So that ventricle contracts, blood is pushed up onto the valve flaps, and the own pressure of the blood basically seals that flap, and blood is not then able to sneak out through there. So the functionality of then the AV valves. So when we're talking about similar valves, they're kind of similar, but there's no chordae, there's no actual strings, there's no papillary muscles. So when the ventricles contract, so we want blood to leave the ventricles into the vessels, so that we want no resistance, we want easy access out. But when then that blood tries to come back in, it puts pressure on the valve flap, and the pressure on the valve flaps then kind of seals these valves together. So again, they work in a similar fashion, but a big distinction, there's no chordae, no papillary muscles, which you can kind of see maybe some problems later in life with these valves as compared to the actual valves inside of the heart, the AV valves. But again, just a little discussion on valve functionality there. With that concludes our discussion on this section. I think that's enough for you to process today. I'll try to find some complementary YouTube videos that kind of give a little bit more detail and sort of a visual, sort of a dynamic portrayal of this. But again, that should keep you for a day or two, and I'll continue to work on more videos and continue uploading as the week continues. So y'all have a good one for now, and I'll be seeing you next time.